Welcome to Astrom Discovery Network, where we embark on a journey to unravel the deepest mysteries of our vast universe. When we look up at the night sky, we see a chaotic scattering of stars, galaxies, and nebulae in every direction. However, cosmologists see something entirely different when they look much deeper into the ancient history of our expanding, observable universe. They see an incredible uniformity, a smoothness that defies logical explanation, based on the standard laws of physics and thermodynamics. No matter where we look, the universe appears to have the exact same temperature and structure in every single direction. This observation leads to one of the most profound puzzles in modern cosmology, known to physicists as the Horizon Problem. To understand this paradox, we must go back to the very beginning, to the moment our universe burst into existence. Imagine a cup of hot coffee sitting on your desk. Eventually, it cools down to match the room's ambient temperature. This process happens because the coffee and the air interact, exchanging energy until they reach a state of thermal equilibrium. But in the early universe, distant regions were separated by distances so vast that light could not travel between them. Without the exchange of light or information, there was no way for these regions to communicate or equalize their temperatures. Logically, one side of the sky should be drastically different from the other, with varying temperatures and completely different physical properties. Yet, the cosmic microwave background shows us that the temperature is uniform to within 1 part in 100,000. How could two completely disconnected parts of the universe know to be at exactly the same temperature at the same time? This is not the only mystery. We also face the Flatness Problem, which concerns the fundamental geometry of our space. If the universe had too much matter, gravity would pull it back, creating a closed geometry like the surface of a sphere. If there was too little matter, the universe would expand forever, creating an open geometry, shaped like a curved saddle. But measurements show our universe is perfectly flat, a state of balance that is statistically extremely unlikely to happen randomly. It is like balancing a pencil on its sharp tip for billions of years without it ever falling to one side. Then there is the third puzzle, the missing magnetic monopoles that should have been created in the scorching early universe. We are used to magnets having two poles, north and south. You cannot have one without the other in nature. However, grand unified theories predict that the high energies of the Big Bang should have produced heavy magnetic monopoles. These heavy particles should be abundant, yet despite decades of searching, we have never observed a single magnetic monopole. These three problems, horizon, flatness, and monopoles, suggested that our standard model of the Big Bang was missing a crucial piece. Enter Alan Guth, a physicist who, in 1980, stumbled upon a radical idea that would change cosmology forever. Guth proposed that a fraction of a second after the Big Bang, the universe underwent a period of exponential expansion. He called this theory inflation, a brief but violent event where space itself expanded faster than the speed of light. Imagine a pea-sized object expanding to the size of the Milky Way galaxy in less than a billionth of a second. Inflation solves the horizon problem by suggesting that everything was once close enough to touch and equalize their temperatures. Then, inflation stretched space so rapidly that these connected regions were pushed far apart, retaining their identical temperature and properties. It also solves the flatness problem, just as blowing up a balloon makes its surface look flat to an ant. Inflation expanded the universe so much that any initial curvature was stretched out, making space appear perfectly flat to us. As for the monopoles, inflation diluted their density, scattering them so far apart that finding one became statistically impossible. It seemed like the perfect solution, a beautiful theory that tied up all the loose ends of the Big Bang. Inflation became a cornerstone of modern cosmology, accepted by almost everyone as the standard explanation for our universe's structure. But science demands evidence, and for decades, inflation remained a theoretical framework without direct observational proof to back it up. In 2014, the world watched as a team at the Bicep 2 telescope in Antarctica made a stunning announcement. They claimed to have detected gravitational waves, ripples in space-time caused by the violent expansion of inflation itself.
This was the smoking gun everyone had been waiting for, the definitive proof that inflation had actually happened. The detection of these beam-mode polarization patterns in the cosmic microwave background was hailed as the discovery of the century. Champagne flowed, and talk of Nobel Prizes began immediately as the scientific community celebrated this triumph of human intellect. But the celebration was premature. Scrutiny from the Planck satellite team revealed a devastating flaw in the Bicep 2 analysis. What they thought were primordial gravitational waves turned out to be signal noise from ordinary interstellar dust in our galaxy. The signal vanished when the dust was accounted for, and with it, the direct evidence for cosmic inflation evaporated. This failure reignited the criticism of Paul Steinhardt, one of the original architects of inflation, who became its fiercest critic. Steinhardt argues that inflation inevitably leads to a multiverse, where every possible outcome happens in some bubble universe. If a theory predicts everything, it predicts nothing. It becomes impossible to test or falsify through scientific observation. Critics claim that inflation has moved from the realm of empirical science into the domain of metaphysics or faith. So we are left at a crossroads, with a theory that explains so much but remains elusive to prove. The mystery of the universe's uniformity remains one of the most compelling drivers of cosmological research in the world today. New telescopes and better detectors are being built, hoping to finally find the subtle signals that will reveal the truth. Until then, we continue to gaze at the smooth, uniform sky and wonder about the violent instant that created it. Thank you for joining us on this deep dive into the cosmos. Stay curious and keep looking up. This is Astrom Discovery Network, signing off until our next adventure into the unknown realms of space and time. Consider the spiral arms of galaxies, structures that emerge from the tiny quantum fluctuations stretched by the inflation event. The cosmic web itself is a testament to the initial conditions set during the very first moments of creation. Even the most extreme objects, like black holes, follow the laws laid down when the universe was just born. We detect waves from these collisions today, confirming Einstein's theories, yet primordial waves remain hidden from our view. Every star born in this nebulae is made of matter that was once compressed into a singularity of infinite density. Imagine standing on a distant world, looking up at the same uniform cosmic background that we see from Earth. Science is not just about facts, it is a dynamic, human process of debate, error, correction, and discovery. We must be willing to rewrite our textbooks when observation contradicts our most cherished and elegant theoretical models. Looking back in time is difficult, but the light from the past carries the secrets we so desperately seek. We are the universe experiencing itself, trying to understand the story of our own origin through logic and observation. Like a cosmic firework, the universe expanded, cooling and fading, leaving behind the smoke that forms our galaxies. The laws of the very small, quantum mechanics, dictated the structure of the very large during the inflation epoch. Perhaps the child looking through a telescope tonight will be the one to finally solve the riddle of inflation. As the sun rises on a new day of discovery, we remain humble before the vast complexity of nature. Einstein gave us the tools to understand gravity, but even his equations break down at the moment of creation. The path to truth is rarely a straight line. It is a maze of dead ends and surprising shortcuts. Just as a prism splits light, inflation split the fundamental forces of nature, creating the universe we know today. Entropy increases, disorder grows, yet the universe began in a state of remarkably low entropy and high order. We piece together the shards of evidence, hoping they will reflect a clear image of the universe's first moments. Time flows forward, carrying us further from the Big Bang, making the traces of our origin harder to find. Theoretical physicists make their moves, proposing particles and fields, while experimentalists try to checkmate them with hard data. From a seed of energy smaller than a proton grew the majestic forest of galaxies that fills our night. The energy released during inflation makes the most powerful thunderstorm on Earth look like a quiet whisper. We have climbed high on the mountain of knowledge, but the summit remains hidden in the clouds above us.
The clockwork motion of the planets blinded us for centuries to the violent and chaotic history of the cosmos. Phase transitions in the early universe were like water freezing to ice, releasing latent heat that fueled expansion. The universe oscillates with waves of sound and gravity, playing a symphony that we are just learning to hear. One single event, the Big Bang, created ripples that are still spreading through the fabric of space today. Our libraries are full of knowledge, yet the book of the universe's origin still has many blank pages. When we enter the realm of the early universe, our moral and physical compasses no longer point to familiar directions. The carbon in our DNA was forged in stars, which formed from the gas clouds shaped by inflation. Theory acts as a lighthouse, guiding observational astronomers through the dark and treacherous waters of the unknown. We polish our theories with mathematics and observation, hoping to reveal the flawless gem of universal truth. Individual galaxies move in clusters and superclusters, following the invisible currents of dark matter and gravity. There is beauty in the mystery, a promise that there is always more to discover over the horizon. Future generations may travel to these distant worlds, seeing the universe from a new and different perspective. Supercomputers now simulate billions of years of cosmic history in mere days, helping us test our wildest theories. Before inflation, the canvas of the universe was chaotic and messy, waiting for a force to smooth it out. When we study the universe, we are effectively looking in a mirror, searching for the origins of ourselves. The universe is a machine of infinite complexity, yet it seems to run on a few simple, elegant rules. Our ancestors sat around fires and told myths of creation. We sit around screens and build mathematical models. Matter diffused through the expanding universe like ink in water, creating the large-scale structure we see today. The same laws of thermodynamics that drive a hurricane also drove the cooling of the entire universe. Symmetry is a key concept in physics. The universe seems to love symmetry, but also needs broken symmetry to exist. Inflation is the bridge that connects the subatomic world of quantum mechanics with the cosmic scale of relativity. Gravity acted as a sculptor, chiseling the gas clouds into galaxies, stars, and eventually planetary systems. Complex structures can emerge from simple rules, just as the complex universe emerged from simple initial conditions. Like a balloon released from a hand, the universe drifted away from its origin, expanding into the void. We are twisting the cube of cosmology, getting closer to the solution, but the final side remains scrambled. Energy flows like water, cascading from high potential to low, driving the evolution of the entire cosmos. Inflation provided a calm eye in the chaos of the Big Bang, a brief moment of rapid smoothing. Life is the ultimate product of this cosmic evolution, the universe waking up to study itself. We are passengers on a train moving at light speed, trying to see the tracks behind us in the dark. The delicate strands of the cosmic web hold the galaxies in place, a structure built by dark matter. Perhaps the answers we seek require not just outer observation, but a fundamental shift in our inner understanding. Destruction leads to creation. The death of stars spreads the heavy elements needed for planets and life. We need a better magnifying glass, better instruments to read the fine print of the universe's history. Even the lightest feather obeys the same gravity that holds the massive galaxies together in their clusters.
We touch the universe with our minds, and the ripples of our understanding spread out to the stars. Time is precious. We have only occupied this universe for a blink of an eye in cosmic time. Some theories suggest a cyclic universe, dying and being reborn from its own ashes like a phoenix. Every discovery opens a door, but behind that door lies another room full of even more mysterious doors. We walk into the fog of the unknown, armed only with the flashlight of science and reason. Is the universe just information processing? Is reality merely a simulation running on a cosmic computer? We are decoding the DNA of the cosmos, reading the genetic code of reality written in the stars. Change is the only constant. The universe is not a static painting, but a dynamic, evolving movie. The heat from within planets mirrors the heat from the Big Bang, a remnant of formation energy. Are we like fish in a bowl, unaware of the vast multiverse that exists outside our observable bubble?
We record our observations, hoping that future generations will make sense of the data we cannot understand. Focus is key. We must focus our intellectual energy to burn through the ignorance that clouds our vision. Physics is the music of reality, and we are trying to write down the score of the symphony. We wish to soar like an eagle, gaining a higher perspective to see the landscape of the universe whole. Every small part of the universe reflects the whole, containing the history of the entire cosmos within it. From the microscope to the telescope, we explore scales of reality that differ by dozens of orders of magnitude. We have left the safe harbor of classical physics and are sailing into the strange waters of quantum cosmology. The climb is difficult and dangerous, but the view from the summit of understanding is worth every struggle. The flame of curiosity is fragile, yet it has survived through the dark ages to light our way today. Sometimes we must revisit old ideas, dusting them off to see if they hold the key to new problems. We are the cartographers of the cosmos, drawing maps of regions we will never visit in person. In the photon's frame of reference, time does not exist. The beginning and the end are one moment. The moon reminds us that we are part of a larger system, bound by gravity to our celestial neighbors. The wave of inflation was a tsunami of space, drowning the universe in a sudden flood of expansion. Are universes like soap bubbles, forming, floating for a while, and then popping into nothingness? We build machines to go where we cannot, to see what our biological eyes are too weak to see. Like flowers turning to the sun, we turn our instruments to the source of light and information. AI is now helping us analyze cosmic data, finding patterns that the human brain might miss completely. The universe emerged from its cocoon of energy, transforming into the beautiful structure we observe today. We walk a fine line between speculation and observation, trying not to fall into the abyss of pseudoscience. We are carried by the current of curiosity, flowing towards the ocean of ultimate truth. Each theory is a lantern released into the dark, hoping to illuminate a small part of the mystery. Cosmology is not fortune-telling. It is the rigorous application of mathematics to the history of the universe. We descend deeper into the rabbit hole, finding that reality is stranger than we ever imagined. We are sketching the portrait of the infant universe,
trying to capture its likeness from faint echoes. One day, we hope to fit the final piece of the puzzle, seeing the full picture of creation. Our perspective has shifted from the center of the universe to a tiny rock orbiting an average star. We fly our theories like kites, letting the winds of evidence test their strength and stability. We are knocking on the door of nature, demanding that she reveal her deepest secrets to us. The true treasure is not gold, but the understanding of how we came to be here. Our footprints may be erased by time, but our discoveries will become part of the human legacy. The fire of discovery burns bright in the hearts of those who dare to ask the big questions. The veins of a leaf follow the same fractal patterns found in the rivers and the cosmic web. We stand on the shoulders of giants, using their tools to see further than they ever could. Understanding our universe helps us appreciate the rarity and fragility of our own home planet. Infinity is a concept that troubles mathematicians and physicists alike. Yet the universe might truly be infinite. Every second that passes is a second the universe expands, growing colder and darker than before. Our theories are written in sand, subject to the tides of new data that can wash them away. We are star stuff, contemplating the stars. The universe developing a consciousness to understand itself. We pass the torch of knowledge to the next generation, hoping they will run further than we did. Sometimes, we need to look at the world through a different lens to see the hidden truth. We chart our course through the cosmos, guided by the stars and the laws of physics. Every rock, every atom, carries the signature of the processes that created it billions of years ago. Inflation is a key, but we are still looking for the lock that opens the door to reality. Light is our messenger, bringing us news from the edge of time and the depth of space. Galileo showed us how things fall. Einstein showed us that falling is just following the curvature of space. The sun is a nuclear furnace powered by the same forces that ruled the early universe. Biology and cosmology are linked. Life is possible only because the universe has specific properties. The flow of blood mirrors the flow of galaxies. Life pulsing through the veins of the cosmos. We wind the clock of theory back to the beginning, but the spring breaks at time zero. Our presence disturbs the universe. Observation collapses the wave function, changing the outcome of the experiment. The story is not finished. The final chapter of cosmology has yet to be written by us. Clouds obscure our view, just as the plasma of the early universe obscured the light of creation. We capture light that has traveled for billions of years, freezing a moment of ancient history forever. We build universes in our computers, testing if our laws of physics can recreate the reality we see. The CMB is a fossil of the early universe, imprinted in the sky for us to find. We are sparks of consciousness, brief flashes of light in the eternal darkness of the cosmos. There is no north in space, no up or down, only relative positions and relative motions. We name the stars, giving them human meaning, connecting our stories to the lights in the sky. We shine our light into the dark caves of ignorance, revealing the beautiful structures of truth hidden within. Order emerges from chaos. The laws of physics guide the random motion of atoms into structured crystals. The pendulum of scientific opinion swings back and forth, settling eventually on the truth supported by evidence. The multiverse theory is like a hall of mirrors, creating infinite copies of reality that confuse us. We must be brave enough to cross out our mistakes, admitting when we are wrong to move forward. Meteors bring matter from space to Earth, connecting our planet to the rest of the solar system. We adjust our theories to bring the blurry image of the early universe into sharp, clear focus.
A single spike in the data can change everything, overturning centuries of established thought and belief. We look for the brushstrokes of the Creator, the subtle signs of how the universe was painted. Laminar flow becomes turbulent. Smooth expansion became clumpy structure, creating the galaxies we see today. We have mapped the Earth. Now, we are mapping the universe, discovering continents of galaxies in the void. Star clusters, like the Pleiades, are families of stars, born from the same cloud, traveling together through space. We send signals into the void, hoping that someone, somewhere, is listening and looking back at us. The universe divided and multiplied its space, creating room for all the matter and energy to exist. If we could turn the clock back, we would see the galaxies rushing together into a single point. Symmetry breaking is like shattering a mirror. The perfect unity is lost, but interesting complexity is created. Scientists put their names on papers, but the truth belongs to everyone, a shared heritage of humanity. We have put our eyes in orbit, looking down at Earth and up at the cosmos simultaneously. Astronomy is the study of the past. We are historians of the universe, reading the archives of light. We can now hear the universe ringing like a bell when black holes collide and merge together. Every snowflake is unique, and perhaps every universe in the multiverse is unique, with different laws of physics. We blow on the embers of old theories, hoping to spark a new flame of understanding and insight. Ancient mariners navigated by the stars. We navigate the sea of knowledge, using the stars as our guide. Andromeda is rushing towards us. One day, our two galaxies will merge in a spectacular cosmic dance. We need new energy, new ideas, to keep the light of science burning bright in a dark world. The very small affects the very large. Quantum fluctuations seeded the formation of the largest galaxy clusters. We cannot stop time, but we can look back to when time began, or when it became meaningful. We must clean the dust from our telescopes and the bias from our minds to see clearly. The circle is a symbol of perfection, but the universe is not perfect. It is dynamic and evolving. Phenomena are transient. We must capture them before they fade, recording the data for future analysis. The image of the early universe is slowly developing in our collective mind, becoming sharper with each year. We connect with scientists around the world, forming a global brain to solve universal problems together. Tree rings tell the history of the climate. The CMB tells the history of the cosmos's climate. From a spark to a star, the journey of matter is a story of gravity winning against pressure. We draw boundaries of our knowledge, but the universe knows no boundaries, extending beyond our wildest imagination. We look at stellar nurseries and see our own origins. The dust that makes our bodies was born there. Sometimes we must turn off our artificial lights to see the true light of the natural universe. The structure of the brain resembles the structure of the universe, a network of connections and nodes. We take the universe apart, particle by particle, trying to understand the mechanism that drives it forward. Is there a mirror universe where time runs backward and everything happens in reverse order to us? There is no end to science, only new beginnings, new questions that arise from every answer we find. The first star to light up the dark universe ended the cosmic dark ages, bringing light to space. The mountains of data we have collected are vast, but we have only explored the foothills so far. We are almost there, yet the last 1% of understanding is often the hardest to achieve. We search for patterns in the noise, hoping to find the secret message left by the Big Bang. The universe will eventually die down, stars will burn out, and only cold darkness will remain forever. We pause our journey to reflect, to gather our strength before venturing further into the unknown dark. The void is not empty. It is seething with quantum energy, particles popping in and out of existence. Science lights the path, but we must walk it ourselves, carrying the burden of curiosity and doubt. We seek a theory as clear and hard as diamond, unbreakable and capable of cutting through confusion. In the silence, we hear the whispers of the cosmos, telling us secrets that mathematics can translate. We smile, because we are the universe knowing itself, a beautiful loop of consciousness and matter combined. Our work is never truly done, but we pause to appreciate how far we have come together. The moon pulls the tides. Gravity connects us to the heavens in a tangible, rhythmic, daily way. We preserve the memories of our discoveries, building a library of human achievement for the future. Even when our screens go dark, the universe continues to run its program, indifferent to our observation. We put away our tools, but our minds keep working, dreaming of new ways to solve old problems. The smoke clears, and we see the stars again, reminding us of the vastness that awaits us. We store our knowledge, passing it on to those who will continue the journey after we are gone. We stand in awe, small but significant, capable of comprehending the immensity of the world around us. We walk home, but our minds remain in the stars, forever changed by what we have learned today. We protect our instruments and our data, for they are the most precious legacy of our species. Time marches on, and we must rest. But the universe never sleeps, expanding and evolving every second. The reflection vanishes, but the reality remains, waiting for us to shine the light of inquiry again. We close the book on this chapter, but the story of the universe is far from over. Thank you for watching Astrum Discovery Network. Join us next time as we continue to question reality.